Okay, in this presentation we're going to look at discrete or random variables. Actually, I shouldn't say discrete random variables. Random variables. So consider two random variables, x and y, okay, and assume that x and y both follow a standard normal distribution, so clearly they're not discrete, but they are not independent. Define the random variables z minus, okay, there's a minus sign there, and z plus to be respectively x minus y and x plus y. So the difference and the sum, essentially. In fact, I do a different video that's very similar to some of this material here. So it's the sum of the difference of x and y. Compute the covariance of z minus and z plus, or z minus and z plus, and based on your answer on part A, in part B, determine if z1 and z2 are uncorrelated. Okay, so what we're going to do here is look at the correlation of z1 or z minus and z plus. Okay, and essentially that is the difference of the two. Okay, and the sum of the two. Okay, so what we're going to do here is just going to expand this expression out. Okay, so we're going to take this x here, and we're going to sort of see what this will get the covariance of each of those terms there. Okay, so you have the covariance of x and the covariance of x and y. Okay, so in this instance, yeah, that's what we got there. That one there and that one there. Likewise, now we look at the minus y from the difference. Okay, and this minus y, and it has a covariance with that and a covariance with that. Now the variance of minus y against plus y is simply minus the variance of y. Okay, essentially you can disregard that, or well, keep this sign outside, but essentially the covariance of y and y is the variance of y. Okay, so variance of x minus the covariance of y and x plus the covariance of x and y minus the variance of y. Okay, so these two terms cancel out immediately. Okay, the variance of x minus the variance of y, and standard normal distribution, that's a bit of a clue there. Okay, the standard normal distribution is, sorry, I meant to do this here like this. I meant to put more detail onto that. 0 and 1 squared. 1 for standard deviation, 1 squared for the variance. So you can rewrite it as 0 and 1 if you want, but understanding that that's the variance. So that's what that comes from there. Okay, just knowing that it's the standard normal distribution, which is commonly called the Z distribution if you want. Okay, so that means that the covariance works out to be 0. Okay, so what was the trick there? Really, it was actually this. It was a straightforward enough calculation, expanding that out, but spotting that helped. I sort of fluffed it at the start, but because I was doing a very similar video to this. But anyway, it's a standard normal distribution, so that's where those ones come from. Okay. So the second part is, yeah, I'll leave that part there for another time. Actually, I'll just talk through the expected value of Z1 is, or Z minus, I keep saying Z1, is the expected value x minus y, which is the expected value of x minus the expected value of y, and so on. The expected value of z plus is the expected value of z, expected value of x plus y, which is the expected value of x plus the expected value of y, 0. And the expected value of z1, z minus times z plus is those terms there. And it is, yeah, as x minus y times x plus y, that's the difference of squares. Expand that out, expected value of x squared minus expected value of y squared. That should equal, in both cases, that should equal to 0. 0 minus 0 equals 0. Okay? And the covariance is worked out using the standard formula there. In conventionally, the covariance of x and y equals the expected value of xy minus the expected value of x times the expected value of y. So essentially you substitute in, that's the standard formula for that, substitute in z minus and z plus. Okay, the sum of the difference. And it works out. 0 minus 0 minus 0 minus 0 times 0, 0. Okay. Now, show that it's uncorrelated. Okay. So, what we're going to do here, what was the question? Determine if they're uncorrelated. Well, essentially, it's a very straightforward enough question. In the first part, we're asked to determine the covariance. Okay. And we found it to be 0 in two different ways. Okay. So this is the calculation here to calculate the correlation. Okay. But necessarily the numerator is going to be 0. It doesn't matter what this is, the variance of the square root of that. Okay. We can work it out, but the denominator, but the numerator is 0. 0 minus the variance of that. It's going to be necessarily, the correlation is going to be necessarily 0. Okay. So they are uncorrelated. Right, we'll leave it there.